Here's another example of a projectile motion problem. Got a boy kicking a soccer ball from the top of a hill, giving the ball an initial speed of 7.2 meters per second, reaches a maximum height 0.35 seconds later. Find the direction he kicked it, the maximum height, the distance the ball traveled in the air. So, we know that the ball reaches the maximum height 0.35 seconds later, and we know at maximum height, the y component of the velocity is going to be 0. Best way to find, and the direction he kicked it, this is going to be embedded in the initial velocity. Direction is the angle. The initial y component of the velocity is going to be 7.2 times the sine of the angle. So the best way to solve this problem is to use good old acceleration equals delta v over time. If we call down negative, acceleration is negative 9.8 equals v final, which is 0, minus v initial, which is 7.2 times the sine of the angle he kicked it at, which I'll call theta, over time is given to as 0.35 seconds. So then doing some algebra, we take negative 9.8 times 0.35 and divide by negative 7.2, so sine of theta equals that. Take an inverse sine. We get that the ball was kicked at approximately 28 degrees, and since it was a positive 28 degrees, we know that is above the horizontal. All right, now we want to find the maximum height. And I realized just now I didn't tell you how tall the hill was. That's important. So let's say the hill is 5.5 meters high. That's a piece of information you would need to answer B or C. So if we want to find the maximum height, the simplest way to do this is to use the time independent equation. We have all these values. Acceleration is 9.8 meters per second squared downward. Delta y is y final minus y initial, which I have now given you is 5.5. At maximum height, the velocity is 0, and our initial velocity is 7.2 sine of 28 whatever. We should use a stored value for that, and that is squared. So we type that in. I store that value as x. So 7.2 sine x squared divided by 2 times negative 9.8 plus 5.5 gets us that I have made a mistake somewhere, because it obviously doesn't make sense that the maximum height would be lower than the initial height. So let's try this again. Let's see, x. I did store it, okay. 7.2 sine of that squared I see, I made a sign error. So there's a negative out in front of that, which I didn't include here. I see. So I make it negative and then divide by negative 9.8. So the negative cancels out. So I divide by 2 times 9.8. And then add 5.5. Okay, all is right with the world. So then we find that the maximum height the ball reached is about 6.1 meters off the ground. Find the distance the ball traveled in the air. Well, that's the same as what we've done several times now. We use the time-dependent equation in the y direction to solve for time, and then we're going to plug that into the x equation, that time into the x equation to calculate the distance. So that's 7.2 sine of 28, using the stored value still, minus 4.9 t squared. All right, and I can't call that x because then I can't punch it into my graph, so I'll change it to a. Go y equals 5.5 plus 7.2 sine of a, of a, I can't click, x minus 4.9x squared. Find our time, let it graph, whoop, okay. Thinking, calculate 0, left bound, right bound. And we get that it takes 1.46 seconds. Okay, now that is stored as x in my calculator. So then we can use that. Delta x equals v naught x times time, which is 7.2 sine of, again, that stored value of 28 times that time that we just found, 1.46, whatever. All right, on my calculator, I've stored the angle as a, and the time is stored as x now, and so we punch that in and find that it goes 5.027, whatever. With sig figs, that would round to about 5.0 meters. So I hope you can see as we've gone through this example and then the ones in the other videos that these are very similar to the problems we have been doing. The math winds up being a little bit more, complicated because there are things that were 0 when we were dealing with our simple cases that now are no longer 0. But this shouldn't be anything new or crazy for you to deal with.